Okay, this is Mr. Martin. These are the video notes for advanced geometry, lesson 7.2. So we're going to be talking about properties of isometries. So remember, in isometry, it's just a transformation where the size and shape of the original figure doesn't change. So one way to complete a translation, so one of our specific types of transformations, is by using ordered pair rules to find the new location of a figure on a coordinate plane. So an ordered pair rule in general looks like x comma y transform to x plus h comma y plus k. So this rule would tell us to move each point h units horizontally. So if h was positive, we'd move to the right, and if h was negative, we would move to the left, and then y units vertically. Similarly, if y was positive, we would move up, and if y was negative, we would move down. So let's take a look at an example. So we're going to use the rule x comma y transform to x minus 2 and y plus 5. So we're going to move each point left, because it's minus 2, and 5 up. Okay, so I'm going to pick a different color here. So let's start with A. I'm going to move 2 to the left, so 1, 2, and then 5 up. So 1, 2, 3, 4, 5 up. So here's my new A, so I'm going to call that A prime. And then I'm going to move B. So I'm going to go 2 to the left, and then 5 up. 1, 2, 3, 4, 5. So here's my new point B, B prime. And then let's do the same thing with C. So 2 to the left, and 5 up. So here's C prime, and D, 2 to the left, and 1, 2, 3, 4, 5. There's my D prime. Okay, then I can go ahead and I can sketch in the figure that I would get, connecting my points. And here's our new figure right there. So you can see it's basically shifted to the left and up. Okay, so that's using ordered pair rules. Let's take a look at an investigation. So at some point you may want to pause the video and work on these 4 parts here. This is going to be for A. This one is going to be for B. And this one will be for C. And then this one for D. Okay, so what we're going to do is we're going to complete the ordered pair rules in each of the 4 graphs to the right. So for part A, in this first one, we're going to transform each ordered pair xy into negative x comma y, and so on for the different ones, x to negative y, and then the last one we're going to switch the ordered pair. So what I would suggest doing first is looking at the original figure and figuring out what each of those points is. So for point A, we can see here we're at 1, 1. For point B, we can see that we're at 3, 3. So these are our original xy pairs. For point C, we can see that we're at 1, 2, 3, 4, 5, and then up 1, 2, 3, so 5, 3. And then for point D, we're also over 5, but we're only up 2, so 5, comma 2. So if you'd like to go ahead and try these on your own, feel free. I'm going to go ahead and pause my video here. So if you don't pause yours in a minute, the solutions for these 4 parts are just going to pop up, and then we can discuss them then. So go ahead and pause now if you want to. Alright, so here are the solutions to the 4 different parts here. So what you may want to do is you may want to just pause the video again so you can double check your results. Separate those a little bit. And then we can kind of go ahead and fill in the chart on the next page. So for part A, we can see we took the whole figure and we basically flipped it over the y-axis here. So this would be a reflection over the y-axis. So let's go ahead and fill that in over here. So the ordered pair x, y transformed to negative x, negative y is a reflection over the y-axis. So let's go back up here and take a look at part B. So part B is kind of similar, except now we've taken the whole figure and we flipped it down. So we flipped it over the x-axis. So let's fill that in. The ordered pair rule x comma y is transformed to x comma negative y is a reflection over the x-axis. And then for part C, if you kind of look at this, if we put part A and B together, if we flip it over the y-axis over into the second quadrant, and then we flipped it down over the x-axis, we would get this. So flipping over the x and the y, that's one of our types of symmetry that we talked about in lesson 1. That's called point symmetry, because really what we're doing is we're rotating the figure 180 degrees about the origin. So this is point symmetry. Point symmetry, or we call it origin symmetry. For that one, so that's 180 degree rotational symmetry, or twofold symmetry. So we've got lots of different names for that. And then this last one, this one's kind of weird, because if I draw in a line here, so notice it's going through 4, 4, 3, 3 or negative 4, 4, negative 3, 3, negative 2, negative 2, negative 1, negative 1, 0, 0, and then we're going through 1, 1, 2, 2, 3, 3, 4, 4. So this line here, if you remember from algebra, is actually the line y equals x. And if we look on either side of that line, we can see it's a mirror image of each other. So what we have here is that we have a reflection over the line y equals x. So this is a reflection over y equals x. So it's really important that you can recognize these different types of transformations, and we'll get some more practice. But if you have any questions, make sure that you pause the video, write down your questions in the margins of the notes packet, and ask me the next time you see me in class. Alright, so let's move on. I'm sure you've heard about using math in the real world. Here's a couple of applications for actually using math in the real world. We're going to look at pool room and mini golf math. So if you have an idea of reflections and transformations, it can kind of give you an advantage with a little bit of practice for figuring out how to hit a ball. Let's take a look at a mini golf hole. So let's say we start here at H, and we're trying to get it into G, and we can see that if I hit it straight to G, I'm going to hit the corner there at D. So what I want to try and do is I have to figure out how to bank it off the walls to get it right to G. So we actually want to end it at H, so we're hitting the ball from G to H. So, but at any rate, we're still going to hit the corner there, and it's not going to go straight to it. So somehow we're going to have to hit it off of this wall, and then hit it off of that wall, and then hit it off of that wall. So what you want to do is you want to work backwards from the hole. Work backwards from hole. So we're going to use the walls as the mirrors. Use walls as mirrors. Okay, and then work backwards. So I'm going to take H and I'm going to reflect it over this wall AF. So I'm going to reflect it over to here. Alright, and I'm going to call that H prime. And now what I'm going to do is I'm going to use the next wall over here. So let's take a look, because if I look at this here, right over here, so now I can almost hit my ball to where that image of H would be. Okay? So if I look right there, if I aimed it right at that H, I still might hit that corner. I'm not really sure. So what I'm going to do is I'm going to do one more reflection. So now I'm going to take this H, and I am 1, 2, 3, 4 away from this wall here. We'll just extend that a little bit. So now what I'm going to do is I'm going to reflect that over this way. 1, 2, 3, 4. So I'll call this H double prime. Okay, and now again, the idea is to be hitting the ball towards any of the H's, and that's going to get us into the real H. So now if I aim over to H double prime, notice where I hit the wall right there. That's the spot that you want to aim for. So now I'm going to hit it right there, and it's going to reflect off of that. And it's actually going to reflect right towards H prime, so it's going to reflect right over there. And then off of there, it's going to bounce off the wall and go right into the hole. Okay, so with a little bit of practice, you'll figure out this process. Now, some things I want you to notice here about the symmetry is that when you hit the wall, the angle that it forms here is going to be the same angle that it forms when it comes off of the wall. Okay, and the same thing here. So this angle over here is going to be the same as this angle over here. Okay, so work backwards from the hole, use the walls as mirrors, and then you want to be aiming the ball at any of those mirrored images, and that will tell you where to hit it. Alright, so why don't you go ahead and you can pause the video now and you can try this one on your own, and when I see you in class, we'll talk about your solutions to this problem. We'll see you next time.